Okay, I'm going to try to give you a really quick quiz review. Okay. Giving you a really quick quiz review. Okay, so first idea here, work inside out on this one. Sine inverse of negative 1/2 you do first. So sine inverse of negative 1/2. Remember, sine inverse, you get in is a ratio, out you should get some kind of an angle over here. Where is the sine inverse negative? In quadrant 4. Remember, it's restricted to quadrant 1 and 4. Cosine is restricted to 1 and 2. It's cosine inverse. So only inverses are restricted. Remember that. So what would give you an opposite over hypotenuse? So here's a -1, here's a 2. So which special right would give you that 30-degree angle? Make sure you have those memorized and written down. So your answer would be backwards -30, right? You got your angle in here. So the answer to that would be -30 degrees. So now this whole thing can be replaced with a -30, so because it's equal. So the cosine of -30 degrees. So now all you have to do is find the cosine. Cosine in the fourth quadrant, right? This is Q4, is positive x negative y. So the cosine of -30 is √3/2. Okay, so next type of problem you might see would be this one here, again working inside out, tangent inverse of 3/4. Okay, so in is the ratio and out is an angle. Okay, draw yourself a unit circle. The tangent inverse is restricted to quadrants 1 and 4 like sine. Put yourself in because it's a positive ratio right here. This is opposite over adjacent. So the 3 goes opposite, the 4 goes adjacent. And this is a nice 3, 4, 5. If you needed to use something, you could do Pythagorean theorem to find this hypotenuse here or a leg. Be careful what you put where. Be careful, I'm saying it again, what you put where. Leg, hypotenuse here, okay? So this just happens to work out to be a 3, 4, 5. Okay, so the inverse tangent, of this ratio equals some angle, which we don't know without a calculator. So now you're doing the cosine, this whole thing goes away, that's that angle. The cosine of that angle that you just drew is adjacent over hypotenuse, or 4/5. And that's the answer to that one. Okay, here's another one. It's a little trickier here. So we have, let me draw another unit circle. Inside out, the tangent of 5π/7. Okay, you have never ever done sevenths. Just go with it. You can do this. We can figure this out. This pi is the same as 7π/7. 1 pi is the same as sevenths. So put it in sevenths. Where do you think 5π/7 is going to be? Right? Halfway through would be 3.5/7, which it's not. It's a little bit more than that. So it's right here. Okay, that would be 5π/7. Okay, so what is that angle right there? 2π/7. Okay, that's your reference angle. The tangent here we will never know, but it's right there. Okay, we don't know sevenths, but now we're asking for the tangent inverse of this angle right here. Okay, which is actually going to be 5π/7, right? Here's the thing. Tangent inverse is only good in quadrants 1 and quadrant 2. Don't know what happened with that. That's supposed to be a Q. Okay, so this thing is way over here in quadrant 2. Well, what are tangents in quadrant 2? They are negative. Opposite over adjacent. X's are negative, Y's are positive. So which one of these two would have a negative ratio? This is always positive. This one over here is negative. So you stick your triangle in here. Okay. If this is 2 pi over 7, guess what this is going to be right here? Okay, 2 pi over 7, but you're going from 0 backwards, so that's negative 2 pi over 7. Okay, so let me say that again. 5 pi over 7, you stuck in the third quadrant. Okay, because 7 pi over 7 is between half of 7 and a whole 7 there, 7/7. It's 5 pi over 7. All right. Second quadrant, though, if you're taking an inverse tan, when you're doing inverse tangent now of 5 pi over 7, you are not allowed to be in the second quadrant. You have to restrict inverse tangent to 1 or 4. You know that the ratio here is negative. So which one of these two is negative? This one here, quadrant 4. It's supposed to be quadrant 4. Okay. This one is negative. So look at the reference angle here. That's the same reference angle down there. So you're going backwards 2 pi over 7. This is your answer to this question, negative 2 pi over 7. Okay, so this one here, we've done this last time. You're going to have something similar. So what's the easy thing if they give you the domain, say like negative 90 to 90? The range of that, remember, this is like a sine function where the midline is negative 4 and you're going up and down by 2. So negative 2 up to down to negative 6. So your range on that is going to be negative 6 to negative 2. Okay. And then you just switch the x's and the y. X is equal to sine y plus 3 minus 4. Solve for that. So x plus 4. Okay, divide by 2. Do the sine inverse. X plus 4 over 2. And then minus the 3. That will give you the y, which is actually the inverse. Okay, and then you switch the domain and the range from the original. Okay, don't want to take too long with that one. Again, you can pause at any place along here or rewind or whatever. This last one, think algebra. Let's get all the tan inverses together here. So let's add tan inverse to both sides. Okay, so you're going to end up with 4 tan inverses here, plus 2 pi equals 3 pi, right? Those are gone now. Let's get the pi's together. So minus 2 pi on both sides. Algebra, algebra, algebra. Okay, so you're going to end up with 4 tan inverse. X is equal to pi. Guess what? Divide by 4, both sides. So you get tan inverse of x is equal to pi over 4. So again, with tangent inverse, in is a ratio, out is an angle. So what ratio do you have for pi over 4 for tangent? Remember, tangent ratio, tangent of an angle is equal to opposite over adjacent, or y is always the opposite over x. That ratio is going to be special right? 45, 45, 90. That ratio is going to be 1. That's your answer. Okay? Thank you. You can go back and pause, replay this, pause anywhere you want. I think the one that you might have the biggest difficulty with, or something you might feel confused about, is this one. So go back and look at that one again, right?